So, welcome to today's class on the use of plastic and the composite materials as the construction material. So, this is the continuation of the class which we had earlier on the use of glass and ceramics as the modern construction material. Let's get into the presentation. The plastic, the plastic you all know that what is plastic. So the plastic as a definition is a general name given to a wide range of synthetic material that are based on polymers. So once again, the plastic is a general name given to the wide range, like numerous synthetic materials are there. So wide range of synthetic material that are based on the polymers. And the plastic is the most versatile material on the earth. It's very adaptable. The plastic is light in weight and still it is a strong material. The use of plastic in construction increases day to day because it is maintenance free structure. Maintenance free means it won't corrode and other problems are not there. Only problem is regarding it is once it's broken or it's out of use, how to decompose it, it's only the problem. The advantages listed for plastic include the versatility. That means it's very adaptable. It can suit in various process, or it can be used in various situations. It has got a high strength to weight ratio, as the weight of plastic is very less, so within a lesser weight you can achieve greater strength. Durability, yeah, no corrosion is coming again. Corrosion resistance, durability in other sense. Then it is easy to transport as it is light in weight and can be folded also. It has got a strong weather ability, so it is resistant to the weathering actions, and they are generally chemically inert. The disadvantages include it has got very low modulus of elasticity. That means very at a very lower load, when you are applying a load, the plastic will stretch permanently. And it is not suitable for the cases where it is meant for applying the load. It is not suitable for direct load application. Then it has got a high embodied energy, and it has got high thermal expansion. So the temperature is always a big problem for the plastic materials. Just to list out the various types of plastic include acrylic, composite, ETFE, polystyrene, polycarbonate, polypropylene, PVC, and PTFE. And the generally the plastics are used as cables, then the pipes and gutters, insulation, membranes, ceiling panels, cladding panel, wall lining, roof covering, sinks. So these are the, so here you can see majority uses are there for the building purposes, like for the cables, pipes and gutters, insulation, ceiling panel, cladding panel, wall lining, roof covering. So if you see all these uses, you can see in no cases the plastic is directly subjected to any load, just for any covering purposes with a suitable objective. That means to maybe to isolate the heat or isolate the sound, and for the convenience of pipe and gutters, and for the aesthetic and other purposes, ceiling panel, cladding panel, etc. It is also used in the, this is plastic balls. The plastic balls are mainly used in commercial kitchens for separation or for wardrobe, and bathrooms, washrooms, ceiling, changing areas, food storage, fast food outlets, and the food processing areas. The reason why we are using the plastic balls in a building, they are durable, waterproof, easy to clean. It's a hygienic wall, cost effective, and it's very easy to install, and you can select the color of your choice. So you can see a proportion of the various plastics used in construction. So PVC is used 54 percentage, while the ABS, nylon, polyethylene are in 3, 9, and 12 percentage respectively. So we find that the plastic is having its own role in the building or as a building material, but not as a primary building material like steel and concrete. And also it is used for aesthetic and for insulation and other purposes. So now recently there is a technology on the plastic flooring. It gives a wood-like finish, and wood plastic is there. It can be used for the doors, and sometimes the ceramics is also replaced by the plastic materials, plastic ceilings figure, and also the figure on plastic roofing. Composite material. The term composite means it is a combination of one or two material. It's very clear. So a composite material is a combination of two or more constituent material which has got improved characteristics when together than they do apart. So if they are using as a single material, they won't have much good property. So we are combining one or two materials to get a single composite material having improved characteristics. So the composites are composed of matrix and reinforcement fibers. So why we are doing this is that if suppose one material is having some disadvantages or some problematic issues, we will combine it with another material so that the combination will be a perfect combination. The matrix is often a form of resin which keeps the reinforcement fibers in position and bonding them together so that the loads can be effectively transferred. So the matrix is offered by the reinforcement fibers which will be helping the material to take the loads effectively. The reinforcement. So we told composites combination of matrix and reinforcement. So we learned matrix is for it is a form of resin which keeps the reinforcement fibers so that the loads can be taken effectively, and the reinforcement it imparts special mechanical and physical properties to enhance the matrix properties. The properties of composite can be influenced by cutting, aligning, and placing the reinforcing fibers in different ways. So the arrangement of reinforcement fibers is a influencing factor on the properties of the composite. The concrete is the most common composite material because concrete is made by aggregate metal. It's coarse aggregate. Then we have the fine aggregate as the sand. Then the reinforcement rebar. Steel is the reinforcement rebar, and cement is the matrix. So what is the advantage of a composite material? So we already learned it's a combination of two or more materials. So advantages: it has got a greater durability in extreme environment. It is lightweight composition, faster construction time. The structures can be repaired in situ, low maintenance. It is flexible in terms of color, shape, and texture. It can be made fire resistant, and high ratio of strength and stiffness to weight is there. So this is the classification of composites uh, basically on the composition. So one is a matrix constituent. So we learned that matrix is a resin which helps to place the reinforcement fibers, and next one is the composites which are derived from the matrix constituent. So just learn the names. You don't want to study in detail. The matrix constituent includes polymer matrix composite. So various short or continuous fibers which are bonded together by an organic polymer matrix transfers the load between fibers through the matrix. So second one is a metal matrix. So this is the matrix is a polymer matrix, and we have the metal matrix and also ceramic matrix. It's consisting of ceramic or carbon fiber surrounded by a ceramic matrix or silicon carbide. So you can just learn a polymer matrix, the metal matrix, and the ceramic matrix, which can be uh, made into the composites. The other one is the matrix derived. So they are the particulate reinforcement composite, flake composites, fibrous composite, and the laminated composites. Just learn the name. You don't want to study in detail. What are the advantages and disadvantages of composite? So you already learned this one. Again, the advantages include typically the strength of the material is increased as a total, because we told that the property is getting increased. They are used for lightweight constructions. It is 80% lighter than the steel and 60% lighter than the aluminum. The strength could be tuned according to the requirements. Rigidity versus elasticity, thermal and electrical properties, corrosion resistance. The various disadvantages include recycling is necessary due to high lifetime. Some raw materials and manufacturing methods are expensive. Expensive. Some manufacturing methods suffer from poor energy efficiency. The strength analyses are usually challenging due to the anisotropic structure of the many composites. So the limitations include high cost of raw materials and fabrication. The composites are more brittle than wrought metals and thus are more easily damaged. Transverse properties are weaker. Matrix is weak, then therefore low toughness. The reuse and disposal is difficult like the composite, and difficult to attach to another material, and difficulty in analysis, and also the cost can fluctuate based on the availability of raw materials. The civil engineering applications of composite materials include smart concrete, basically the concrete which is having the cement matrix and the reinforcements, rehabilitation and the retrofitting. It means strength or some collapse structure, how to improve the capacity. It's called rehabilitation, and retrofitting is strengthening the failed structures. Advanced composite materials for highway bridges, road bridges, and for FRP, fiber reinforced plastic doors and door frames. Thank you.